Okay, in creating the drawing sheet of the cow catcher, we are going to want to dimension this trapezoid, and we want to do it in a view where we're looking at it in its true size and shape. If you're ever looking at a surface that is not normal to your view, it's not perpendicular to your view in all directions, then it's going to look foreshortened. Things look distorted and might look bigger or smaller than they appear. And so this is an angled surface, and it's not just a regular angled surface, it's angled in more than one way. It's like a compound angle. Okay, so from the front view, that corner is further away than this corner, correct? Okay, but it's not just angled kind of front to back on the right. It's also going from the bottom to the top. It's being angled. And so that's what we call a compound angle, all right? So it's not just, you know, if this right here, from a top view, to understand, if this edge on the top was in line from my this top perspective with the bottom, then it wouldn't be a compound angle. We would only have it being sloped backwards as we go kind of left to right from the front view. But it's not just sloping as we move to the right, it's also sloping as we move from the bottom to the top. So, within the drawing sheets, using the auxiliary view button is not going to be very helpful. It's going to be quite a bit more difficult. So, this is a much easier way to create a normal or orthographic view of this face. Basically, we'd never want to see these lips on any of these edges. I want to know that I'm viewing this thing orthographically and that none of these edges are showing up, right? Because I can twist all around and kind of try to get it, but if I can see a little bit of a surface there, that means I'm not perfectly looking at it that way. All right, so one is how to do it here in the Part Studio. Note that I'm in the Part Studio. And then how to get that view over onto my drawing sheet. So first off, I'm going to click on that face that I want to be normal to my view. I'm going to right click, and I have an option here in this is my right mouse button menu. Sometimes when you're on help forums, they abbreviate this menu as the RMB for right mouse button. So view normal to shows up, and it kind of snaps it that way. Now this could work, but what if I want this bottom edge to be horizontal? That's just kind of what I want. Seems nice to me, okay? So if I select an edge, so I clicked in the white to deselect that face, and I'm selecting this edge. If I select that edge and then right click, I get an option. I wish there was an align to horizontal axis, and I don't, but I do get an align with vertical axis. And that's needed because if I try to rotate this around, I never could get that bottom edge horizontal. Okay, but it snaps in increments that are a factor of 90 degrees, and so if I get this to be vertical, okay, and then I rotate, those increments will get me to 90 degrees based on that edge. So using the bottom as a reference, you know, just where my tabs are, you can see that that is horizontal now. Okay, so I've gotten the view. Now I need to save or name this view so that I can bring it onto a drawing sheet, because this is not a standard view that you're going to be able to create. So Onshape has a thing called named views. All right, so we're going to give this view a name, and then we're going to see how to create a named view and then how to reference or pull up the named view. Now again, it's important to note that we're doing this inside the Part Studio, because in the drawing sheets, when we try to bring this view on, we have to know that that's where we created it. Okay, so from this view, I'm going to hit this drop down, and where's it? Named views right here under isometric, etc. You have a section called named views. I'm going to click that button, and there are no named views created right now. Oh wait, there's is there? Yeah, there's some. I've already done this, but I'm going to call this demo aux for auxiliary cow catcher. Okay. And then I'll hit the little plus sign to add that view, and now it should be added to my list. So we've created a named view for this Part Studio. So once we're on our drawing sheets and trying to create a drawing of the cow catcher, we want to bring in, let me go here, I had a blank sheet ready to go. I want to bring in a view of the cow catcher. So I'm going to hit Insert, and I'm going to choose the part I want. And instead of the orientation being one of our standard orthographic views or standard isometric, you can see that some of the other angles, view angles, that have been created as named views from the Part Studio show up. So the one I just created was called Demo Ox Cowcatcher. You will see that brings the cowcatcher on at that exact same orientation. I had done a couple other ones before, and again, I did those in the Part Studio, so they're there. In my first attempt, you can see that I didn't get that edge to be horizontal, but I just felt like I would like that to be horizontal. So if you saw me how to left-click that bottom edge to align it to the vertical axis and then rotate it, get it to horizontal, I feel like that's a nicer view. So anyway, but that was how to create a named view and then how to get that named view onto your drawing sheet. So there you go. One last little step with the cowcatcher is going to be creating a section view. So we'd want to not only understand the dimensions of this trapezoid on the face, but to understand the depth, we would now create a section view right through that feature on this auxiliary view. And then we'll be able to see, I'm not really laying this out too carefully, but that is the view where now I can see and understand the true dimension of that cut. This is not looking at that foreshortened or anything. This is kind of the perfect perspective to understand that and its true size and shape as well. So just some key things is, why do we do this? Because now we're able to dimension, say, those distances, this offset distance of the trapezoid, and it's happening in its true size and shape view, and then as well as that dimension here. So those are critical dimensions that we were going to want to show on our drawing sheets, and we wanted them to do from the perspective where they have not been foreshortened. Okay, I hit pause and brought on a couple of other views just to re-emphasize that idea that we want to dimension things when they are in their true size for us and they don't look foreshortened or maybe for lengthened, if you will. And so I brought a different view of the cowcatcher on, and I did that section view again. Hopefully you can tell that that trapezoid looks a little out of proportion because we're looking at it where we have that compound angle. Things are sloping away from us as we go to the right. They're also sloping away as it's going up. And then when we were talking about the dimension of this cut, you can see that that cut is even hard to get a view to dimension that. Or if you say, okay, well, let's not dimension that cut, but let's dimension the material that's left, the thickness. The thickness of that material here is not 0.064, okay? And Onshape is using the dimension of these lines that's based on the way it was cut, and that's not actually the thickness of that material because this has been skewed. It's sloping towards or away from me, depending on how you look at it. So that's not the true thickness, you know, front to back of that shape. So if you do not get an auxiliary view of this face, then you also don't get the ability to create a section view that's perpendicular to that to get an accurate depth dimension for there. So that thickness was 0.05. Hopefully when you made the cowcatcher, you realized that we did a shell, and we shelled out the cowcatcher so that the thickness left behind of the cowcatcher was 0.1. And then we did this trapezoid and did that extrude remove to create that recess on the face. We extruded that 0.05, exactly half of 0.1. So we should know already that this 0.05 is the correct dimension. And seeing that should prove to you that, yeah, something's wrong, and that's not the actual thickness. So hopefully you can understand that what they're dimensioning here is based on the views and that we just aren't looking at it at the right angle. Okay? So there you go. I hope that really helped you out to understand and get the correct views of your cowcatcher.